Hey Don.
Guten Morgen.
Good morning. I just wonder what makes a 3DCS user go for the next step of collaboration in the quality with QDM?
You know, it's an interesting question, Uli. We always think about, we start in this world of simulation, and the question becomes one of, okay, I'm simulating and I'm doing it based on a certain set of parameters, but those parameters, let's say it's, tolerance conditions, ultimately ends up being statistics that relate to production also. But the difference between, the outcome of a simulation versus what is real, what is the reality of the outcome. That's always a challenging point. And so then we get into this conversation of, are we talking about specific cases, like how do two specific parts fit together, or are we talking about general trend of, okay, how is this part and all of its statistical, let's say, brothers and sisters going to fit together with another set of parts that are the statistical representations of its brothers and sisters. So that's an interesting question that we're still always are challenged by.
Yeah, that's a good point, John. I'm always also thinking about when you're measuring a single part, how to scale up to the final assembly to figure out what does that mean to the overall quality expectation. So, and this is what we call reverse engineering, where we bring back the physical measurement data to our simulation. And I very often compare it to FEA models, No FEA guy will tell you he can calculate against a physical world, because he cannot. But he can calculate against a approach, and then he crash the car in the wall or throw the chicken in the engine of an airplane and see what has happened when the reality step into the game. And then he rework his simulation model, and the crash into the wall of a car is our physical measurement. So bring it back and then see what has happened when the physical world step into the game. So it's, especially when you're talking about sheet metal parts, it's mostly not the deviation, but the tendency, the mean shift. And when those come together, what does that mean for our quality? And yeah, this is, I think, a very good way to do that. And I believe it is not a challenge to simulate that, but work at the data from in an easy way. That is the challenge that most people focus on. This is where I think QDM can help a lot, right?
Yeah, so there's two really different problem sets that we have to consider. One is when you talk about doing a simulation, you get a result, a statistical result, and it doesn't matter if the quantity of product is going to be a very small number, maybe 5 or 10, or it's going to be a large number, maybe 50 or 100,000. The real challenge becomes one of the problem that the 5 or 10 assembler or manufacturer has is every one of them is usually of some kind of high value. So being able to say, okay, part A and part B, how are these specific parts, let's say serial number, common serial number for this assembly, how are they going to fit, and are they going to fit? And if they are not, what adjustment, might be shimming, might be tool adjustment, what kind of adjustment needs to be made? So it's one problem that has to be addressed. The second one is when you talk about the 50,000 or 100,000, that is a entirely different problem, but yet can be addressed by the same data, because it's now, instead of looking at the individual case, you're controlling the process. So the process is what is very important to look at, and it becomes a question of, okay, what adjustments do I have to make in my process? What do I have to monitor about the process? Because usually the rate of production for these is very, very high. So it's fast. It's a fast production process. So the requirements are different from the standpoint of looking at process versus individual instances or serial number, but the requirements are really the same when you talk about how does the data align from one part or one process to the other process, or other part or other process.
Yeah, it's again good points, and it remind me to something out of my career. When I was responsible for parts, so I'm the product owner, and I have to deal with, for example, nonconformances. I get always the question, can I confirm? Can I live with? Yes or no? And I had to make a decision. So first of all, I'm always referred to my E3WH, So at least getting the information that we're facing nonconformancy, facing an issue. Then I need to understand, where do I face that issue? And why it has happened. It's also important to me. And what does that mean for the quality, overall quality, and how to manage, So it is very important for nonconformancy, if this has happened on a single part, maybe we find in our assembly process some ideas how to work around. When you have, for example, a very expensive part, which you normally would send to trash, you never will do, because it's incredibly expensive. You have to find other solutions. And this is where we can help to get an overall view and find a solution. Maybe we have to shim a tool somehow different. We have to use a different handling check, whatever. But how can we work around to avoid to bring that part to the trash,
Yeah, that's a very good point. So the differences in these requirements are quite significant, but yet the ultimate requirement is, how do I use this information to understand where I'm going, whether it be on high value, low volume kind of parts as you're talking about, or if it be the controlling the process of the high volume, high production environment that may be common of things like the electronics or the automotive industry.
Right, and very important point is, you don't have time for weeks, You have to be fast, you have to be precise, you have to be on the point. So what can deliver all that need? And for me, it's QDM. It's fast, it is easy, it's on the point, and with 3DCS we can close the bridge of scaling a single part to the overall requirement by bringing in the assembly process.
So this is really the idea of digital transformation. Everyone in our manufacturing world these days is concerned and focused on digital transformation, and the question becomes one of, how can I apply digital transformation in the quality world to the requirements of low volume, high complexity, and high volume, fast production?
Yeah, and when we're talking about digitalization of a process, that means in the downstream processes we are having less work because we are digitized, right? But this also means at the beginning of our journey we have to have as precise as we could, because in all the complete process there is no human involved to do the correction action, you know? Looking to a drawing, see, oh, it's wrong, but I know what Don meant, and I changed it in that way. So we have to be precise at the very beginning because the robot just read it in.
Right.
And QDM and 3DCS can exactly deliver that we are precise at the very beginning. 3DCS really address our quality needs, see what do we need in point of quality, tolerance concept, tolerance value, datum system, measurement strategy. We also can simulate how should we produce the part in point of tool strategy, clamp strategy. We have the raw material and we drill the shaft, so what will be the result and so on. And then it's all about having the quality under control during the whole process to end of life. How can we manage that? That's QDM.
So we've heard, what I heard you say is we've really improved our process through the use of simulation to better understand and better define what are the product requirements, but also what are the process requirements for manufacturing and inspection. And now we're also talking about not only requirements, but we're talking about actual results to be able to collect all of the measurements, use those measurements to validate the actual product requirement and to validate to what the expectations were based on the simulation. And bringing this entire, we like to talk about closed loop, truly closing the loop between the simulation prediction and the actual measured results to be able to more quickly and more efficiently manufacture product.
Yeah, that's right. And this gives me a headlight. I always asking, would you like to manage the total cost of quality, or should the total cost of quality manage you? So,
very important question and very big priority from our perspective at DCS as we consider how we are going to help our customer lower cost of quality. Thank you.
Thank you.
It was great talking with you today.
Yeah, thank you. The same to you.